You know, you can't help but notice lately that the universe actually does exist. Pretty neat, right? But why? Why does anything exist? Isn't it equally, if not more likely, that nothing should exist instead? Or is there something fundamental about the nature of reality which means the universe was destined to begin and endure? Let's find out as we ask, why does the universe exist? Starting at number 5. There's no such thing as nothing. The Big Bang is the most commonly accepted explanation as to how our universe sprang into existence. But what triggered this spectacular event? Why did the Big Bang even occur at all? Surely it's easier for nothing to happen than something. Otherwise, it wouldn't be so satisfying when your friends cancel your plans. Oh, I don't have to leave the house and get dressed and shower. Oh, thank God. But according to quantum mechanics, which is the study of super tiny business that even ants don't know about, the idea of nothingness persisting for all time is unrealistic, as there's no such thing as empty space. Even in a perfect vacuum, there are particles and antiparticles which flash in and out of existence. They come from nowhere, and they return to nowhere once they're done. We've never been able to observe such particles for very long because they're incredibly unstable. But this just goes to show how things can genuinely appear out of nothing. So, even if there was an endless void in place before the universe flashed into existence, that condition, it turns out, is as fertile as compost when it comes to sprouting particles, planets, and universes. But where did our universe and these phantom particles come from? If there was genuinely nothing on our plane of existence, then did our universe arrive here from somewhere else? And if so, what's to stop it happening again? Ooh, double universe! That sounds so fun. At number 4, because nothing is unstable. Another field which attempts to explain why the universe exists is general relativity, although she and quantum mechanics rarely make for cozy bedfellows. Scientists have struggled to reconcile these two for a long time. But when it's general relativity's birthday and quantum mechanics puts out, we end up with some interesting ideas. Stephen Hawking discovered as much when he tried to describe black holes by applying quantum theory to the smallest scale of space. Hawking found that space is unstable, and rather than being a smooth, uniform void, empty space and time eventually actually starts to froth bubbles like a dog with a mouthful of dish soap. These bubbles of space-time form spontaneously out of nothing, just like those weird particles we mentioned. And we think a similar bubble may have formed out of nothing to create our entire universe. But if that's true, then why haven't more bubbles formed since? And isn't it a bit of a leap to go from a tiny quantum bubble in space-time to a gargantuan universe of 1 trillion galaxies? That's some weight gain, pal. So how does that work? At 3, because of cosmic inflation. Inflation theory claims that in the fraction of a second after the Big Bang occurred, the quantum bubble of space-time which created our universe did so by expanding at an incredible rate of speed. At no time at all, this bubble went from being smaller than an atom's nucleus to the size of a grain of sand. And while this may not sound like much, it's actually mind-blowing. A nucleus is typically 10,000 times smaller than an atom. And if anything were to increase by that much, you'd sure as heck know about it. It's like a pea suddenly expanding to the size of a sports stadium. And this is just the difference between a nucleus and an atom. In a single grain of sand, there are 50 million atoms. That's 50 quintillion, or 50 with 18 zeros after it. So, just one tiny pea will blow up to form 50 quintillion Fenway Parks, Old Trafford's, and wherever the heck the Toronto Argonauts are playing this year, all in a fraction of a second. This rapid expansion fits in with our current understanding of the Big Bang, but it also tells us some more interesting things. It explains why the universe's cosmic radiation background is so neat and uniform, and it tells us our universe is flat. At 2, because we're flat. Our universe's space-time is theorized to exist in one of 3 different forms: flat as a pancake, curved outwards like this banana, or it curves inwards like this other banana. Based on calculations made according to inflation theory, we think we know the answer. It's flat. And this conclusion is crucial if our other theories about the universe are to hold up. Many of the ideas we've spoken of are only possible in a flat universe, as its rapid expansion would have required a heck of a lot of energy. But in the flat universe model, this energy comes from the gravitational forces of the matter within it. In a curved universe, there would have been an imbalance, and inflation wouldn't have been possible. But a flat universe has the balance required to allow a tiny quantum space-time bubble to inflate all the way to our fancy-pants universe with stars, planets, life, and that subway on the corner nobody goes to because it smells like a wet dog. And by the way, remember when we asked if these space bubbles had formed more than once? Well, Stanford's Andre Lind says they have, and that this may be the key to how the multiverse exists. And at number 1, the perpetual creation. When we think about a time before our universe existed, we tend to imagine endless space, with reality just waiting for our universe to fill it, like an understuffed burrito. But this is a very universe-centric viewpoint, because according to Andre Lind, these bubbles have been expanding and creating universes for all time. And they'll continue to do so forever. Our universe is surrounded by empty space, and in this space, more bubbles form, with each capable of creating another universe vastly different to our own. In these universes, there may be 8, 9, or 10 dimensions instead of our 4. They might have a completely unique array of matter. Gravity might be purple. 4chan might be a wholesome Christian activity board. Everything is possible if the inflation theory is correct. And due to the bizarre nature of space-time, these other universes may exist on the same level of existence, or on a completely new plane to our own. So, to return to the question we asked at the beginning, it seems the universe exists because of 2 basic principles: that something can erupt from nothing, and that given an infinite amount of time, space, or both, everything that can happen will happen. Therefore, it is simply impossible for universes to never come into existence if you waited around long enough. And the reason we are here to question this is because we just happened to be created in one of the moments when something happened. But is this a coincidence? Or is there something else to the universe we've not quite hit on yet? Obviously, without the conditions for life, we would never be able to know what the universe is, because we wouldn't exist. But would the universe exist if we were not here to perceive it? We're going to explore this idea in our bonus video, The Conscious Universe, which you can watch on our Patreon page at patreon.com/Strange Mysteries. For a $2 a month pledge, which you can cancel at any time, you'll get to watch this and all our bonus content, which goes deeper and darker into every topic than YouTube allows. If you don't want to donate, then it's cool. We won't stop perceiving the universe just to be spiteful, but we will strive to continue to provide the best content possible under YouTube's restrictions. As you'll find out by watching our recent video on the meaning of life in relation to the universe.